Alright, this is your video on reviewing complex numbers and solving quadratics in preparation for the first part of the Unit 2 test in the spring of 2015. If we're looking at our very first problem here, 3x squared equals 10 minus 13x, the first thing I need to do in order to solve it by factoring is get it set equal to 0. So I'm going to subtract 10 and add 13x. So I'm going to rewrite it. 3x squared plus 13x minus 10 is equal to 0, okay? Because my a value is not 1, the strategy I'm going to use to factor it is I'm going to kidnap. So I'm going to take the 3 and I'm going to hide it in the c value, making my polynomial now x squared plus 13x minus 30. Now I can create my two sets of parentheses to factor it because my a supposedly is 1. So I have an x and an x. So now I'm asking myself what multiplies to be negative 30 and adds to be positive 13. Well, that would be 15 and negative 2. Okay? But kidnapping is illegal, so I'm going to take the 3 that I had kidnapped and place it in as a coefficient for x. Notice that 2 came back. Well, one of them's a fake, and so to determine who's a fake, I need to check my sets of parentheses for a common factor. 3x plus 15 have a common factor of 3. So I'm going to pull out the 3, and I'm left with 3 times the quantity of x plus 5. Now here's the fun thing with kidnapping and these fakes. When you find a fake person in your life, you get rid of them. So I'm going to get rid of this 3 because it was a fake. So now, by the zero product property, I can set my factors equal to 0. So I have x plus 5, and I set it equal to 0. And I have 3x minus 2, and I also set that equal to 0. This one is going to produce x is negative 5, and this one produces my solution of, well, I add 2, and then I divide by 3, so 2/3. So my very first answer for number 1, if I can zoom in properly, is the solution set, which is what these brackets are, of negative 5 and 2/3. All right, so now let's take a look at our next problem here. Our next problem, number 2, is already pretty nice, except for the fact that number 2 is not set equal to 0 either. So I'm going to subtract 45 onto this side of the equation. And so then we have x squared plus 4x minus 45, and this whole thing is equal to 0. Now I can just automatically set up my factors. So we have an x, and we're asking ourselves what multiplies to be negative 45 and adds to be positive 4? Well, the answer will be 9 and negative 5. So we have x plus 9 and x minus 5. We set both of our factors equal to 0 by the zero product property. And essentially, this is what causes us to flip our signs. This one produced an answer of negative 9, and this one produces an answer of positive 5. So I can once again give myself a solution set bracket. We have the solution set of negative 9 and positive 5. All right, let's take a look at our next question here. In our next question, what is the integer solution of 6x squared plus 9 is equal to 21x? So once again, we actually need to get our equation set equal to 0. So I'm going to subtract the 21x onto the left-hand side. Create some boxes to separate what the problems are here. So we have 6x squared minus 21x plus 9 is equal to 0, okay? The very first thing that I can pull out actually from all of these terms is a 3. Notice that 3 goes into 6, 21, and 9. So I'm going to factor out a 3, and that leaves me with 2x squared minus 7x plus 3 is equal to 0. Now because this is an equation and I'm set equal to 0, I can actually just divide both sides by 3 because it's going to cancel out on the left-hand side, and 0 divided by 3 is still 0. So 2x squared minus 7x plus 3. Now once again, I'm going to take my 2, I'm going to hide it in my 3. I'm kidnapping. And then I have this polynomial. I can create my factors. X times x is going to get x squared. So now I raise the question, what multiplies to be positive 6 and adds to be negative 7? That would be negative 1 and negative 6. Now I'm going to take the 2, place it back in as a coefficient for x. Now to find the fake, I'm going to take the greatest common factor, both sets of parentheses. My very first one did not have one. And my second one, I can pull a 2 out of both terms, leaving me with x minus 3. And the 2, we just erase from our lives. All right, so now the question did ask for the integer solution, and 2x minus 1 will give me an answer of 1/2, and 1/2 is not an integer. So their answer is 3, which is why the only answer in this problem is an answer of 3. You could have, in a test-taking situation, noticed the fact that 1/2 is provided, but 1/2 is not an integer, and that's actually why C is incorrect. All right, number 4 and number 5 are done in the same style. We need to write an equation when we're given the solutions. So let's make some observations. Notice that in this last problem, we have 2x minus 1 producing a root of 1/2, and x minus 3 producing a root of 3. So in this problem I have, where I need a root of -6 and a root of 2, -6 means my factor was x plus 6. And 2 meant my factor was x minus 2. Because if you set these factors equal to 0, you would get the solution in the opposite sign. So now all I need to do is FOIL. X times x is x squared. X times -2 is -2x. 6 times x is positive 6x. And 6 times -2 is -12. We can combine like terms, so we get the polynomial of x squared plus 4x minus 12. Zoom in, write that down. Oop, there's my pen. X squared plus 4x minus 12. Now what about when it's uglier and we have 2/3 and -4? Well, let's start off with the -4. -4 meant that my factor was x plus 4. When you're looking at this 2x minus 1 from this previous problem over here, notice that the coefficient of the x became the denominator of our fraction, and the numerator of our fraction was our constant term in our factor. That's why we have 3x minus 2 as our factor, because if you set 3x minus 2 equal to 0, you add 2, and divide by 3 and get a root of 2/3. Now my job's a lot easier and I'm not having to worry about multiplying fractions. My apologies, Mr. Sunny. Oop. All right, back again. Sorry, Sunny had stopped barking. All right, so now all I need to do is FOIL out my binomial, and it's a lot easier because now I don't have fractions involved. So x times 3x is 3x squared. X times -2 is -2x. 4 times 3x is 12x, and 4 times -2 is -8. Again, we combine our like terms, creating the polynomial 3x squared plus 10x minus 8. Zoom in and write my answer for number 5, 3x squared plus 10x minus 8. All right, we're almost there. We're halfway. Now it says solve each equation by using the square root property. So the square root property is the reason why in completing the square, we're actually able to take the square root of both sides. So the thing we need to check in all of these problems is whether or not they actually provided for us a problem that was already a perfect square trinomial. So in number 6, we have x squared plus 8x plus 16 equals 36. So I'm looking at the left-hand side here, and I'm noticing what multiplies to be 16 and adds to be 8. Well, that would be 4 and 4. Notice that they're the same factor. That's why it's creating this perfect square trinomial of the quantity x plus 4 squared. Now I can solve using the square root property by taking the square root of both sides. And whenever I take the square root, we're always going to place a plus or a minus in front of our radical. The reason we do this is because this quantity in here could be negative or positive, because a negative number squared is still going to produce a positive solution. So now we have x plus 4 is equal to positive or negative, and the square root of 36 is 6. So then lastly, we just need to subtract 4. So we have negative 4 plus or minus 6. So negative 4 plus 6 is negative 2, and negative 4 minus 6 is negative 10. That is why we have our two solutions. And then for number 6, we write our solution set, negative 10 and 2. All right, let's take a look at number 7. Number 7, we're also using the square root property. And we have our problem, x squared minus 2x plus 1 equals 45. So once again, I'm checking to see if it's a perfect square trinomial on the left-hand side. And so I asked myself, is there anything that multiplies me 1 and adds me negative 2? Well, that would be negative 1 and negative 1, creating the perfect square trinomial of x minus 1. So then this is squared equal to 45. I'm going to take the square root of both sides, getting me x minus 1 is equal to the square root of 45. And it's plus or minus because, once again, it could be a positive or a negative underneath that radical. Now 45, we need to determine whether or not we can break this into a factor tree, helping us simplify a radical. Well, 45, that's really the square root of 9 times the square root of 5. And the square root of 9 is 3. So we have x minus 1 is equal to positive or negative 3 radical 5. Last things, we add 1, so we have 1 plus or minus 3 radical 5. And these are not like terms, so we cannot add them. The reason they're not like terms is because this 3 is being multiplied by the radical 5. All right, so for number 7, our solution, we have 1 plus or minus 3 radical 5. Notice that these are irrational solutions because a radical is not a rational number. Now for number 8. Number 8, oh, that looks scary because we have a big coefficient here. So we got 25x squared plus 20x plus 4 is equal to 3. Okay. Once again, I'm checking to see if it is a perfect square trinomial, and the good guiding light is 25 and 4 are both perfect squares. So this is going to factor into 5x, and then I'm trying to figure out what number here will help me fill this in, and it's actually going to be positive 2, and I'll show you why. So 5x times 5x will get me 25x squared. 5x times positive 2 is 10x. This one's also going to produce a 10x, giving me the 20x. And then 2 times 2 is 4. Okay? All right, so let me erase this because I don't need it because the factor appears twice. That's the reason why we are allowed to say squared. All right, so the next thing that I need to do is I'm going to take the square root of both sides. And we get 5x plus 2 is equal to the positive or negative square root of 3. And the square root of 3 cannot be simplified. So 5x is equal to, so we're going to subtract 2. So negative 2 plus or minus radical 3. Oops. And then we divide by 5. So then our answer is negative 2 plus or minus the square root of 3 over 5. All right, zoom in and write our answer for number 8. Ooh, too far. Sorry about that. Okay, so negative 2 plus or minus square root of 3 over 5. 2 more to go, 2 more to go. That was my little excitement. Click the wrong button. All right, so now we are going to complete the square in number 9 and number 10. All right, so where do I have room to write these things? Here we go. So x squared minus 10x. Notice that it's already set equal to our constant term, which was the goal. And I'm just going to give my little space here. A value is 1, so I don't need to divide everything by my a value. So I can set myself up to complete the square. And I'm going to add my square onto both sides. And to complete the square, I'm going to take my b term. I'm going to cut him in half and square it. So negative 10, half of him is 5. 5 squared is 25. Okay. So then on the right-hand side, we have 11 plus 25 is 36. And on the left-hand side, it creates our perfect square trinomial of x minus 5. because negative 5 times negative 5 is 25, and negative 5 plus negative 5 is negative 10. Now I can take the square root of both sides. So we have x minus 5 is equal to the positive or negative. The square root of 36 is 6, so then we add 5. So x is equal to 5 plus or minus 6. So we have 5 plus 6 is 11, and then 5 minus 6 is negative 1. So these are our two solutions here for number 9. Write that in my answer box here. So we have negative 1 and 11 as possible solutions. All right, last problem. So once again, I got really lucky here because my coefficient for A is just 1. So we have x squared minus 4x plus 29 equals 11. All right, so first thing I'm worrying about is the fact that 29 needs to get out of my way. So I'm going to subtract 29 from both sides. So we have x squared minus 4x, and 11 minus 29 is negative 18 here, okay? So now I'm going to complete the square. And to fill in my square, I'm going to take my b term, cut them in half. That's negative 2. Negative 2 squared is 4. So then we can create our perfect square trinomial, x minus 2, because negative 2 times negative 2 is positive 4, and negative 2 plus negative 2 is negative 4. And then we have negative 18 plus 4 is negative 14. Now we're going to take the square root of both sides. So x minus 2 is equal to the positive or negative square root of negative 14. Now anytime I see a negative under a radical, that tells me that I can pull out an I because our root is imaginary. And the square root of 14 can actually not be simplified. So we have x minus 2 is equal to the positive or negative I radical 14. So lastly, I'm just going to add 2 onto both sides, and we get our solution of 2 plus or minus I radical 14. Write that in on my box, and then ta-da! We obtained mastery on our quiz today. 2 plus or minus I radical 14. Let me just zoom out one last time. That way you can see all the solutions in all their glory and check all your answers one last time. All right, now we're going to look at some other questions. First off, we're going to simplify the square root of negative 180. Whenever I see a negative underneath a radical, I automatically know that I can pull out an I because I is the square root of negative 1. Next thing I'm going to try to break down is 180. Well, 180, something I do know for sure, is the fact that 180 divided by 9 is equal to 20. So 9 times 20 is 180. Well, the square root of 9 tells me so far I can pull out a 3. And now I'm dealing with the square root of 20. 20 can also be broken down. The square root of 20, that's really 4 times 5. And the square root of 4 produces 2. So now we have 2 times 3 times I times radical 5. So my final answer is 6I radical 5. That is now completely simplified. Next question. What is the complex conjugate of 2 minus the square root of negative 4? Well, first let's adjust this square root of negative 4. So we know the complex number we're dealing with is 2 minus, well, the square root of 4 is 2, and the square root of negative 4 would be 2i. So the complex conjugate of 2 minus 2i will be 2 plus 2i, because we simply will just change the sign. Now, looking at number 3, we have 7i to the third power. This is really saying 7 to the third power times I to the third power. So 7 to the third power is 343. Let me space this up, that way you can see that this goes with this problem. I to the third, one way of looking at this is I squared times I. Well, I squared, an important fact to recognize, is I squared is equal to negative 1. So we really have this expression here of 343 times negative 1 times I, leaving me with the answer of negative 343i. All right, now let's take on this big problem here, this big long expression, and you're going to recognize this probably from your Sysman account, and that's fine. But let's go through it and take it piece by piece. first off, we have negative 5, and we're going to distribute this into the 7i. This gets me negative 35i times the quantity of negative 2 plus I. Okay? Another thing I can do is I can be dealing with this other set of parentheses where I must FOIL. 7 times negative 2 creates negative 14. 7 times positive 2i creates positive 14i. Negative 7i times negative 2 gets me positive 14i. And negative 7i times positive 2i gets me negative 14i squared. All right, let's keep going. Now we're going to distribute this negative 35i into parentheses here. So when I distribute negative 35 into my parentheses, it gets me 70i minus 35i squared. Now let's look inside this quantity in parentheses. Notice we have a 14i and a 14i, so this can be combined. 14i plus 14i creates positive 28i. I squared, well, that's equal to negative 1. So we really have negative 14 times negative 1 getting me positive 14. Now we can continue simplifying. 70i, once again, I squared is negative 1. So we have negative 35 times negative 1 getting me positive 35. Negative 14 plus positive 14 cancels out, becomes 0. So this is really all we're left with. 70i plus 28i can be combined to become 98i. And then here's our real part of 35. This is our value for A, he's our real part, and this is our value for B, the integer coefficient for our imaginary part. Okay? All right, let's look and see what's next. In number 5, we are dividing. And whenever I'm dividing, it's important to recognize I cannot have imaginary numbers in my denominator. So I must multiply both the top and the bottom by the conjugate of my denominator. The conjugate being negative 9 minus 6i. And I'm going to multiply both the top and the bottom here. So all I'm essentially doing is FOILing. I have a binomial times a binomial. So negative 9 times negative 9 is negative 81. Now we have 9 times negative 6i, getting me negative 54i. Now we have 4i times negative 9, getting me negative 36i. And then 4i times negative 6i, getting me negative 24i squared. In the denominator, this is the difference of two squares of the form a plus b times a minus b, where a is negative 9 and b is 6i. This always produces a squared minus b squared. So my denominator, I really have negative 9 squared minus my b squared, so 6i squared. Well, negative 9 squared is 81. 6 squared is 36, and then I squared is negative 1. So in our denominator, it's really 81 plus 36, getting me a denominator of 117. Oops, lost my pen there for a second. Erase that. Oop, didn't work. Okay, 117. So my top, now I just need to combine some like terms. So we have negative 54i and negative 36i. That's going to combine to become negative 90i. Denominator is still 117. And then here we have negative 24 times I squared. Recall I squared is negative 1, so it's really going to be plus 24. So negative 81 plus 24, which will get me negative 57. So here we have our expression, negative 57 minus 90i over 117. But our job is not yet done because I can actually simplify this expression further. Is there a number that goes into 57, 90, and 117? We can essentially divide all of our terms by 3. Negative 57 divided by 3 gets me negative 19. Negative 90 divided by 3 gets me negative 30i. And 117 divided by 3 gets me 19. Oops, not 19. That was what 57 divided by 3 was. My apologies. 117 divided by 3 gets me 39. So, of course, I can still break this up into separate parts. Negative 19 over 39 minus 30I over 39. And if you choose to leave your answer like this, you can actually simplify 30 over 39 even more. Notice that, once again, this is a complex number of the form of A plus or minus BI. All right, let's keep going. Looking at our now section on solving quadratics, we have this problem. The quantity of x plus 3 squared equals 9. In this problem, it's actually most efficient for me to use our square root property because we've already isolated this problem. So we have now x plus 3 is equal to, now please recall, whenever you take the square root, you put a positive or a negative. So the square root of 9 is 3. So now we're going to have to subtract 3. So x is equal to negative 3 plus or minus 3. So negative 3 plus 3 is 0. And negative 3 minus 3 is negative 6. So my two solutions are 0 and negative 6. All right, let's see what's problems next. Oh boy, it's a real world problem. So let's read it together. On March 12, 1999, Adrian Nichols broke the world record for the longest human flight. He flew 10 miles from his drop point in 4 minutes and 55 seconds using a specially designed aerodynamic suit. Using the information at the right and ignoring air resistance, how long would Mr. Nichols' flight have been free falling had he not used his special suit? We're going to use this formula where t is in seconds and the initial height, h sub 0, is in feet. All right, so a few key pieces of information provided to us. Our initial height is going to be 35,000 feet. So our equation is negative 16t squared plus 35,000. Okay? Now in this case, I'm trying to figure out where are we with t when I open my parachute at 500 feet. Okay, so what that 500 feet is actually going to be is my value for h of t, because our function here is in terms of distance. Now I want you to start to take something to heart. Anytime you are solving a quadratic, you want to get it set equal to 0. And the sign that I'm solving a quadratic is because I have my term being squared. So I'm going to subtract 500 from both sides. So I really have negative 16t squared, and 35,000 minus 500 is going to be 34,500. Okay? Now, when you're solving quadratics, you have many different options. We can plug this into the quadratic formula, or we can complete the square, or maybe we could factor. But in this problem here, actually, I'm just going to solve like a normal equation. I'm actually going to move the 34,500 back onto the other side. The reason I got it set equal to 0 is because I want you to recognize that this is a quadratic. So 34,500 on the other side equal to negative 16t squared. We are going to divide both sides by negative 16. So then we get 2,156.25 is equal to t squared. I'm going to take the square root, and the reason I'm not worrying with the plus or the minus here is because t is time. We cannot have a negative time. So our only answer here is going to be positive. So 46.435 is our value for t, and this is in terms of seconds. All right, so now let's look at our very last problem. We're completing the square. First things first, we are going to subtract 5. So we have 2x squared minus 10x is equal to negative 5. Because we have an a value of 2, I'm actually going to divide everything by 2. So we have x squared minus, well, 10 divided by 2 gets me 5x. And over here we have negative 5 halves. Now I'm going to complete the square, add a square on both sides. All right, and I'll show my work. So we are going to take negative 5, we're going to cut it in half, and we are going to square it. Well, negative 5 squared is 25, and 2 squared is 4. And that's what's going to fill in our completing the square box, 25 fourths. 25 fourths. And hopefully you remember the pattern. This is always going to be half of my term here, which is why it's negative 5 halves, okay? And on this side of my equation, we just need to get a common denominator, one denominator 4. So we're going to multiply both the top and the bottom by 2. So we have negative 10 fourths plus 25 fourths. That's going to get me 15 fourths. Okay? Now, take the square root of both sides. X minus 5 halves is equal to plus or minus the square root of 15 fourths. Now, just like we did on the previous problem, we are going to essentially be able to distribute our radical because we have division happening and there is no addition or subtraction. So we have the square root of 15 over, well, the square root of 4 is 2. So we have x is equal to, we're going to add 5 halves on both sides. So 5 halves plus or minus the square root of 15 over 2. And if you want to condense that into one expression, we're going to condense it like this.